Hello, and welcome to the beginning of Chapter 1, in which we're going to introduce some fundamental ideas in chemistry. This chapter is entitled Chemical Foundations, and I first want to introduce what chemistry is. So, as many of you know, chemistry is the study of matter. Matter is defined as anything that has weight and takes up space. So, you can think of it as stuff. Chemistry is the study of matter and its composition, its properties, its structure, and the changes that it undergoes. The changes that matter undergoes are, in this context, known as chemical reactions. So a lot of times in this class, I'll abbreviate reactions like this, just so you get used to that abbreviation. And how bonds are broken and bonds are formed is going to be a major topic throughout the 2 semesters of general chemistry. So this is what we're studying in general chemistry, matter. How we have come to understand so much about the chemical world is really through applying what's called the scientific method. So you probably get this in a lot of your science courses, an introduction to the scientific method. The scientific method is grounded in conducting observations, and observations are made via measurements. We kind of talked about that a little bit when we were doing our little math review, but measurements can be both qualitative, for example, looking at something change color, for instance, or looking at a reaction give off a gas. But many observations are also quantitative in nature. So quantitative measurements would consist of a number and a unit. An example of a quantitative measurement would be weighing something on a balance and recording its mass, for instance. You would record its mass with a unit such as grams. So observations, which are really just a series of measurements, can be both qualitative and quantitative in nature. Once you have many, many observations under your belt, you can start formulating natural laws. Okay, so this is what scientists have done. Many, many observations have given rise to laws that are truths based on many, many observations. So you need lots and lots of observations to be able to declare something a law, because a law means that there are no exceptions. There are actually relatively few natural laws, but certain things uh, have no exceptions. The law of gravity, the laws of thermodynamics. So, the first law of thermodynamics is that energy can neither be created nor destroyed, and that is an immutable natural law with no exceptions. The other laws of thermodynamics, such as the second law that the entropy of the universe is always increasing, are also incontrovertible, no exceptions. In addition, you want to try to explain nature. You want to try to explain the natural laws. And in order to do that, scientists theorize. So, theories are just explanations that scientists devise to explain what's observed in nature. So theories can change. As you make more observations, you modify your theory. So as you kind of learn more about a subject, your theory can evolve and improve and change. And good scientists are always being skeptical and asking questions and modifying their theory to make it better reflect what's true in nature. Scientists also make predictions, and another word for scientific predictions is hypotheses, or the singular hypothesis. So predictions or hypotheses would be the basis for experiments that you perform, say in a lab. So this is really scientific method stuff. A hypothesis is a statement that you make, and then you do an experiment to try to prove the hypothesis right or wrong. Okay, so experiments are conducted to test the hypothesis, to validate or improve a theory. Okay, so hypotheses can be proved or disproved, but this is what kind of lets us explore the natural world and lets us kind of get closer to the truth of what's going on in nature. So that's the introduction to the scientific method.